In this video, I'm going to walk you through the steps associated with testing the hypothesis that levels of soft drink consumption may be associated with different levels of aggression in children. This is based on the Suglia 2013 study. I mentioned in the textbook that the sample size was much larger than what I've got here. I changed the sample size to be smaller so that the analysis would be a little bit more interesting. And what you'll see is that in order to address this question, it will take putting together a lot of the pieces of information that you'll learn throughout the unit. And so I think for that reason, it's going to be quite interesting. So let's first of all go through our steps. Check the dependent variable is continuous. These are aggression scores that I think go from 0 to 100. And so they obviously look very continuous to me. And so that gets a check mark. Now, number of groups. This is where it gets interesting. You can see that there were 0, 1, 2. Actually, we can analyze it. Let's look at the number of consumption groups there are. And you'll see that there are some children that reported 0 soft drink consumption, 56% per day on average. 1 soft drink, 25%. 2 soft drinks per day, 10%. 3 soft drinks, 4.5%. And 4 soft drinks a day, 4% of the sample said they had 4 soft drinks a day. And so the question is whether different levels of soft drink consumption are associated with different levels of aggression. And what you should note here is that these data are not really, they're not nominal in nature and really in any way. They are genuinely an interval ratio type of scale. In fact, they're a ratio scale because you can have 0, and that's meaningful here, having no soft drinks a day, and then 1, 2, 3, 4. Now, what I see in a lot of papers is that they will analyze these data with a one-way between subjects ANOVA, which is not entirely, it's not a wrong thing to do, but it's not necessarily an optimal thing to do. And so let's carry on and see how that might impact the results. So I'm still going to consider doing a test of the difference between means, and even though really what I could be doing is possibly a correlation. So let's check for normality and outliers before I carry on across each group. So go into Analyze, Descriptives. So I got aggression goes in the dependent list, soft drinks into the factor list. Click on Statistics. Make sure you have outliers selected. And on plots, make sure you've got the histogram, not the stem and leaf. And continue. And we'll see if we have any skewness or outlier situations. And you can see that skew and kurtosis are very low for all the categories of soft drink consumption. This kurtosis, negative 1.8, still not a problem because it can be as high as 9 before it really becomes something you want to look at. And we have skewness and kurtosis for the 4 soft drink group, still very good. One thing we will note is that sample size is definitely unequal, 112, 50, 20, 9, and 8. That could potentially have consequences, especially if we have homogeneity of variance assumption violated. We'll check that later. In terms of outliers, let's just go straight down to the box and whisker plot with the outliers. And we can see that there are only 2 warning signs here in the 1 soft drink per day. Because these do not have stars next to them, they just have circles. It's only a warning you can disregard for the purpose of this analysis. I will note, looking at this plot, that it does look like there's an increasing trend in central tendency for aggressiveness in children across the soft drink levels of consumption. So we've got 6 groups to consider, 5 groups rather, and let's check to see if homogeneity of variance assumption has been satisfied. Let's go into general linear model. So let's put aggression in a dependent variable box, soft drinks, and fixed factors. And let's look at the plots. We've already looked at the plots, but we'll look at them again. It's not going to be, oh, you know what, it will actually have a trend to it. So, and options, we want to click on homogeneity of variance. So you want to click descriptives, estimates of effect size, and homogeneity tests. And click continue. And for post hoc tests, we are going to do Tukey because, well, if we satisfy the assumption of homogeneity of variance. So select Tukey in case we do satisfy the assumption. So let's see what happens. We, in fact, did satisfy the assumption of homogeneity of variance with Levine's test. P is greater than 0.05. So this simplifies things for us. Sample size is unequal. That's okay. And here we go with the analysis. And we can see that soft drinks as a factor, independent variable, with 4 and 194 degrees of freedom, F 1.41, the p is not less than 0.05, it is 0.231, and therefore we have not rejected the null hypothesis. And here's the estimate of effect size for the omnibus effect. So even though we didn't reject the null hypothesis, we'd still want to look at the effect size, and it's 0.028, which is 2.8% of the variability, but it's not statistically significant. So we've checked homogeneity of variance, we've conducted the analysis. In terms of the ANOVA has been done, it's not significant, and so I do not expect to see any significant Tukey results. I don't actually have to look at the ANOVA when I do a Tukey, because a Tukey is a single-step procedure, but I'm just pointing it out to you for thoroughness. We get a correspondence in the results here. None of the p-values are statistically significant. And so a lot of researchers would stop here and think, well, soft drink has no impact on aggression levels, and so we failed to reject the null hypothesis. But something you need to focus on is the fact that the independent variable has some continuousness to it. It's a ratio scale, and you are losing statistical power when you conduct ANOVAs on data of this nature, and I see it often that people will treat this sort of variable as a nominal scale variable rather than an interval ratio or ordinal. And so there are two ways to go about this. One is we could do the linear contrast analysis and specify that there is a linear trend which increases power. And I'm going to do that in a minute. But really what you could do here is simply a Pearson correlation. So bivariate correlation, very simple analysis, putting the two variables into the appropriate box, clicking OK, and what I get is a correlation of 0.163, and it's actually statistically significant, 0.021. So because that p-value is less than 0.05, I can say that there is a relationship, a statistically significant relationship, between the amount of soft drink that somebody drinks and the level of aggression that they reported. I think it was the parents who reported the aggression level in the children. So when observer reported aggression levels in the children and the amount of soft drink that they drink, which I think was also reported by the parent, there's a positive correlation. Now, really, I should look at the level of skewness associated with aggression, because it might be very skewed. So in fact, I know it's going to be skewed. It's just a question of whether it's excessively skewed. And it is, oops, I went into aggression there. And we have skewness of 1.536. Now that is lower than the 2.0 expectation. And so we should be fairly confident about the result, but I could still back this up with a bootstrap analysis. So let's go into bootstrapping. I got 1,000. You probably would be good to choose 2,000, but I'm going to stick with the default just to save time. And so I'm doing the bootstrapping because the skewness of 1.5 is getting close-ish to quite high level of skewness. And so I just want to really back myself up with this analysis in order to be confident that there is less than a 5% chance of fooling myself into suggesting there's something going on in the population level. And we can see that the bootstrapped 95% confidence interval goes from 0.01 to 0.320. And because the confidence interval is both on the positive side and the point estimate is positive, I can reject the null hypothesis here. Even with the more confident bootstrapping result, I'm confident that there's a statistically significant effect here. So imagine that, collecting all these data on a very interesting type of study, which is sugar consumption through soft drink and aggression levels, stopping with the ANOVA and saying, we failed to reject the null hypothesis, not even close. And all the multiple comparisons, not even close. And then doing the actual correlation and finding a result. So that is an example of pulling all your resources together based on the knowledge that you have about data and the level of measurement and statistics that'll help you get an interesting result, and arguably a more accurate one in the end.